Good morning, class. So today I'm going to start 8255 programmable peripheral interface. So this is basically it is an 40-pin IC. So it provides some additional feature with the I/O devices. So you can say PPI 8255 is a general purpose programmable IC. This is a programmable I/O device designed to interface the CPU with the output world such as ADC, DAC, keyboard, etc. Or you can connect any sensors with the help of ADC, mouse, keyboard. These all are I/O printer. So we can program according to the given conditions. It can be used almost with the any microprocessor because it is additional IC. So it consists three ports, basically port A, port B, and port C to connect the I/O. As you can see, this is the pin diagram of 8255 IC. So these are the port A, PA0 to PA3, and remaining are here is because each port are of 8-bit. This is basically 8-bit port. This is PC C port, and this is B port. You can see here. Another important thing is port C is divided into two parts. So you can use PC0 to PC3, and or you can use PC4 to PC7. So it has two different groups in C port. This is the block diagram of 8255 PPI. So it is required plus 5 volt and ground power supply. So this is one control word register. Through this register you can program your 8255 PPI, and this is a read write control logic. So with the help of this logic you can select the port A, port B, or port C. So you can select any port with the help of this A1, A0 and chip select signal. So this is group A, PA0 to PA7. You can connect any, you can use, this is at IO port. PC0 to PC4 and PC4 to PC7. This is the port C, different. As you know, this is divided into two parts, lower bytes and higher bytes. This is port B. This is the pin layout, PA0 to PA7, port A, PB0 to PB7, port B, PC0 to PC7, port C, and the remaining pin. These are the data pins. These can be used as input or output pins. D0 to D7. These are the data pins for the transfer of data. Reset pin to reset this whole IC PPI. Read bar and write bar simply for read and write operation. Chip select to enable this chip. This is active low signal basically. A1 to A0, this is address pin. So we can provide the address to this IC. Next is the block diagram. So port A, port B, and port C. I told you about the control word. So this is basically 8-bit register. You can program this register or you can change the mode of your 8255 PPI with the help of, by changing its bit either 1 or 0, you can change its mode. So basically it works in two different modes. You can select these mode with the help of this control word register. So this is 8-bit register. So bit, this last bit, D7 bit, if it is 1 means it is connected to the IO mode. If it is 0, so by 0 and 1, 1 for IO mode, and if it is 0 means you are selecting the BSR mode. This BSR mode is bit set reset mode. So later I will tell you about this. So this is simple IO mode if D7 is 1. Further in IO mode there are three different types of classification. Number mode 0, mode 1, mode 2. So basically when you are changing the bit D7 from 1 to 0, so you can change its mode. So chip select A1 and A0 if all are 00, that means port A is selected and address is 80H. If this is 001, port B selected 81, this is the port address. 010, you can select port C, port address is 82H. If it is 011, that means control register. So later I will discuss about this. Means you are selecting the control register if it is 011. And for 100 means IC is disabled, so there is no selection. So depending on the value of chip select A1, A0, we can select different ports in different mode as input output function or BSR mode. In BSR mode directly actually it port C bit you can directly use as 1 or 0 as input and output. So directly you can send the data to the port C in the BSR mode. Okay. So you can set or reset any bit of the port C with the help of this mode. This is done by writing a suitable word in the control register. So by changing the bit from D0 to D7, you can change the BSR mode or IO mode, or you can use BSR mode only with the help of control register. So this is the block diagram. So this is the internal decoding. It is available inside the 8255 this circuit. So chip select and A1 A0 you can with the help of chip select A1 and A0 you can choose any port for connection of the IO port A, port B and port C. 11 is for control register. So this is basically write operation enable. So this is the how to generate the port address. For example, if you want to use the port A, so address should be 80. So how to generate the chip select with the help of this? You have to generate 80 means port address. Port A address is 80H. So how to select this port address? So simple, use the address bus A0 A1 and this is A2 A3 and this is 1 0 0 0 0 0 and to select this port A A1 and A0 should be 0 0. If this is 1 0, that means you are selecting port B, so address is 81. So by changing only A1 and A0 you can change its port selection you can change. Number one mode is bit set and reset mode. So if MSB of control word D7 is 0, if this is 0, then PPI works in BSR mode. In this mode, only port C bits are used for set or reset. Okay, so port A and port B will be unchanged. Only port C, you can set or reset any bit of your port C with the help of bit D7 and D3, D2, D1 and D0. So in BSR mode, how many bits are useful? From D0 to D3 and D7. D7 is used to select the BSR mode. If it is 0, that means it is in BSR mode. So which bit you want to set or reset, so it depends on the D1, D2 and D3 value. So you can see here if you want to select bit 0 of port C as set 1, so what should be the value for this control register, it should be 0, 0, 0, 1. Means 0 bit of port C will be set 1. If you want to set the 7th bit of the port C, so what should be the D1, D2, D3? It should be 1, 1, 1. And if you want to reset this 7 bit, means it should be 0. So easily by changing the D1, D2, D3 bit, you can choose any bit of port C for set or reset. Next is input output mode. So for input output mode, D7 bit should be 1 and remaining bit D5, D6. With the help of D5 and D6, you can choose the different mode of PPI. So as earlier I told you, it works in mode 0, mode 1, mode 2. So for mode 0 selection, D5 and D6 should be 0, 0 for mode 0. For mode 1, it should be 0, 1 and 1, don't care. So this is for M0, M1, M2. So this is mode selection of port A. It depends on the D5 and D6. D4, this is for basically IO function of port A. That means if it is 1, 1 means input, 0 means output. So if it is 1, that means more port A will be input. If it is 0, that means port A will be output. D3, D3 also IO function of port C. So if it is for upper bit of port C, upper means PC4 to PC7. Same if it is 1, that means input, it is 0, that means 1. So port C upper bit will be input output, you can change with the help of D3. Similarly, D2 is used for selection of the port B. Either port B you want to use in mode 0 or mode 1. So if it is 0, that means mode 0. If it is 1, so port B it is in mode 1. So D1 is again IO function of B. If it is 1, so port B will be input, or it is 0, then port B is work as output. So D0, it is IO function of port C lower bits, means PC0 to PC7. So you can change PC0 to PC7. It is 1, that means PC0 to PC3 can work as input. If it is 0, that means output. Okay. So this is the function of word register. With the help of D7, you can change. Next is input output mode, mode 0, mode 1. So mode 0 is simple or basic IO mode. In this, port A, B, C can work either as input function or output function. So this output are latched, but the input are not latched. It has interrupt handling capability. In mode 1, handshake or stopped IO in either port A or B can work, and port C, bits are used to provide handshaking. The output as well as input are latched. It has interrupt handling capability before actual data transfer to the transmission speed of the CPU and the printer. So with the help of one example, you can understand. Example is when CPU wants to send data to slow peripherals device like printer, it will send handshaking signal to the printer to tell whether it is ready or not to transfer the data. When printer will be ready, it will send one acknowledgement to the CPU, then only it can transfer data to the data bus. So this printer will send data from D0 to D7. So first printer will ask to the CPU, it will provide the acknowledgement, CPU will provide the acknowledgement, then only data will transfer from uh, printer to from CPU to printer. Mode 2 or bidirectional IO mode. In this mode, port A will be work port B can either in mode 0 or mode 1. Okay, and port C bits are used as handshake signal. The output as well as input are latched. It has interrupt handling capability. Control register is as follows. For mode 2, you can see the D7, it should be 1 for IO mode because it is a part of IO mode. So for selection of mode 2, what should be the value of D5 and D6? For mode 2, it should be 1 1 or 1 0. Okay. D4, this simple IO function for port A. D3 for upper or higher bits of C. D2 for mode selection of port B 0 or 1. So D1 simple, you can use port B for 0 or 1. D0 IO function of PC port lower bits PC0 to PC3. So they can use either 1 or 0 input or output. This is one example how to use PPI IC. So the problem is write a program to read the dip switches and a display the reading from port B at port A. Means you have to read data from port B and display at port A, from port CL at port CU. Means from two ports, from port B and port CL, you have to read the data and display to the port A and port CU. So as you know, port A address, port B address and port C address. So it is 8000H. Actually this is for 16-bit because 8085 has 16-bit data bus. So address is little bit modified. It is 8000H because of 16-bit data bus. For port B, 8001, 8002. Okay. So remaining things are same. A1 and A0 it should be 0 for selection of port A. This is 0 1 for selection of port B. So this is a simple circuit diagram. As you can see, dip switches are connected to the port B, B0 to B7. This is port B, and from PC0 to PC3. This is the lower bits of C port. But these are also acting as the input. Dip switch is connected to the this port B and PCL. So you have to read data from here and you have to display the port C, C4 to P7, and from PA0 to PA7 it will be output. Means if it is 1, so it will be off, 0 this LED. If it is 0, that means this LED will glow. So as you can observe the position of dip switch as the output.